Hello to anyone watching this. This is a project that I've done. Uh, Here's the GitHub page. The about says takes in an image as input and performs operations that change the brightness, contrast, and gamma contrast of the input with hard-coded values. Also benchmarks these operations running on the CPU and GPU. So I basically made these functions to change the brightness, contrast, and gamma contrast on the CPU and GPU. And by hard-coded values, I just uh, I just input a random number to change the brightness, contrast, and gamma contrast, and that was basically it. So to explain my code, here's main. I just ran one function, which was the benchmark function that takes in the input image path and it takes in the output image path too. So it knows where to put these output images. So you know whether it's working or not. Image utils. I use the pill library for uh, using images and stuff. So the first function, load image to array, it converts a pillow image into a RGB NumPy array. You need to put the convert RGB here because otherwise if you leave it out, it will default to RGBA and that'll just mess up with everything. Uh, Save image is so that it saves the image to the output right here. And let's go to CPU to see the functions. Uh, First one is change brightness. We take in the image array and the amount we want to change. So first we create an output variable that just gets the image array that we took and it casts it into an int 16. And then right here we for looped through each pixel basically. So the image array is of the form height, width, and color channel. So basically, let's say your resolution is 1920 by 1080. Uh, it will go 1920 times here for the height, and then width is 1080. And then this for loop basically just does three things, but you just put it like that. So now then I create a variable new value and I just apply the brightness formula, which is just adding the amount to the output. And then I want to store this into the actual output image array that we are changing. And since an image is, or each pixel has a value 0 to 255, we want to clip it so that it doesn't go below 0 or over 255. And we return the output and we recast it into a uint8, unsigned integer 8. And then for change contrast, we take an image array and a factor. Uh, we just change factor to float or we cast it. and then just applying a formula for the contrast scale. And then we basically do the same thing here. We have an output image array, but we changed it to a float 32 since we are multiplying by a factor. We're not just adding a number. And then for loops are basically the same. And we apply the formula to get the new value for the pixel. And then we store it again in the output array. And we recast it into a uint8. And for a change gamma contrast, it's basically the same. Taking a factor, yeah. And then this, we have this formula which we normalize first. We normalize the array that, or the pixel that we have already. So then it goes from 0 to 255 to 0 to 1. Then we apply another formula, which is what I put in normal result. And then the actual new value that we obtain will be normal result times 255. And we'll put that in the output array. And then return the casted output. So that is the CPU functions. So that's basically what it is doing on the GPU too, but this is more simpler. So now we'll go into the GPU. Okay. We'll start with the wrapper first, since this is actually doing all the work. The wrapper is just setting things up. So right here, we created an image tensor, which is converting the image numpy array into a or this should be image array to a numpy array that contains torch floats and selects GPU. And then you want to create an output tensor with torch empty like image tensor. And then the HWC, we grab the dimensions of the tensor, which is just like the CPU. The dimensions are the height, width, and then the color channel. And then calculating them are pixels is easy, just your resolution, which is given height times width. And then this is the change amount, the amount that you want to change, but we changed it into a tensor, so then it doesn't have any problems casting or anything. And we create a grid using a lambda function and using ceiling division with this. So basically, how many Triton kernels are we executing? And we do ceiling division on the number of pixels and block size. So now we call to the kernel just like this with grid right before the parameters. We've taken the image tensor, the amount we want to change it by, output, number of pixels, and the block size. You can auto tune this block size, but I just put 1024. And then after we call the kernel, it will already have stuff into the output. but we need to change it back into a NumPy array. And we do it like this. It is so then it can reread the image. Okay, going up to the kernel for the brightness, we take in this is the tensor that we passed in right here, image tensor, we passed it in. And this is basically going to be the pointer to our pixel. Then we take in change amount. We have the output pointer, number of pixel, block size. And we start with the program ID. We start at 0, of course. And then we initialize the start of our block with our program ID times the block size. So we know where we are starting in each block. And then pixel offsets, it is just going to be basically which pixel are we modifying inside that block. So basically we have the start of the block. Let's say we're at block 2. So we'll be at block 2 and then plus uh, an array from 0 to block size. Or not array, but just 0 to 1024 in this case. This mask, it makes sure that our offset that we choose does not pass the number of pixels, so it wouldn't do unnecessary computations. Now we load the RGB values and the other parameter, make sure the garbage values in mask will just be 0. So for the RGB value, we'll have the pixel pointer plus the pixel offsets. So basically, we have we gain access into the tensor, and then we add the offset. So where are we in the block? Like which pixel are we in? And then we multiply it by 3 because the values is RGB. That's how it's formed. Like that's how the color channel is formed right here. So you multiply by 3 and then plus 0, 1, 2 because that is how the offset is. This would be plus 0, this would be plus 1, and plus 2. So now we get a output variable for all the RGB values. So basically we're just applying the same formula we did in the CPU, like this. And then we store these values again, but we store them in the output pointer. So it's basically the same thing as pixel pointer, except these are empty values now, and we are just changing them. And we use the R out, G out, and B out. So that is the brightness one. And after explaining that, everything else is basically the same thing, except it's a different formula. Just like this. This is basically the exact same, basically, except for this is change factor, and we changed it to float 32. Okay, we changed the float 32 here, but it's basically the same, except this part and the formula. So I won't really explain this because it's basically explaining the same thing, but in this kernel, uh, I had to install another library to do powers. And then I won't really explain the benchmark one, that this is kind of vibe coded because the point of this project was just to learn Triton, how it works, how to manipulate kernels and stuff. Yeah. The output of this program should look something like this. So the CPU runs for about 26 seconds or something, and the GPU is 16 milliseconds. For the brightness, contrast, you can see the numbers. The GPU is obviously way faster. These numbers look a little different just because I'm recording and stuff. So for the input image, you can change it. I just have this random photo I took in a video game. And then the output images should look like this. So CPU brightness and GPU brightness should look the same, which yes, it is. And then contrast, they're the same. Gamma, yeah, the same. So yeah, this project is uh, that's basically it for this project. Also, you can you can change the image if you want, but you need to change this path. Output doesn't really matter, so just change this path if you want to change the image. And yeah, that's basically it.